In order to figure out correlation, we first need to create a scatter plot. A scatter plot is a graph for bivariate data. Bivariate means two variables. So bivariate data is data where we have two pieces of information for each data set. There are three types of correlation. When we make a scatter plot, one of the ways that the information can be correlated is this way. If we read this graph from left to right, as x increases, our y decreases. This type of correlation is negative correlation. The second type of correlation is the opposite of negative correlation. If our scatter plot looks like this, if we read this graph from left to right, as x increases, our y increases. This type of correlation is positive. It goes up from left to right. And the last type of correlation that we can have is if we make our scatter plot and the information is just all over the place, we really can't see a trend that's going on, we would say that this data has no correlation. Now, if we have negative correlation, we're going to have a line of best fit. And that line of best fit for a negative correlated set of data will be negative. And for positive, the slope of the line of best fit will be positive. If we have no correlation, there is no line of best fit. One of the things about correlation is, mathematically speaking, we can prove correlation. In fact, we can come up with a number that tells us how correlated the data is. And the closer that number is to 1, the more correlated that information is. What we cannot prove is causation. What that really means is, just because two sets of data are correlated, that does not mean that one causes the other. If we made a correlation, a scatter plot, that looked at the Earth's temperature over time versus the number of pirates in the world over time. Well, as the Earth's temperature has gone up, the number of pirates in the world has gone down. There is a correlation between these two sets of data, but there is no causation. If there was a causation, in order to stop the Earth's temperature from rising, all we would have to do is increase the world's pirates. So there definitely is correlation here, just not a causation. If we looked at the map of a major city, and we made a grid of the map of a major city, and we looked at the number of cops on duty versus the number of murders in each district in a major city, as the number of cops on duty increased, the number of murders in that district will actually increase. Now there is a correlation here. The more cops on duty, the more murders there are. But that doesn't mean that there's a causation. The more cops are not causing more murders. This happens for a couple different reasons. If there's more cops on duty, more murders are going to be solved, so there's more murders where there's more cops. Secondly, if there's a whole lot of murders in a district, there's going to be more cops on duty in that area. So there definitely is a correlation, just not a causation. If we look at a scatter plot and we decide that there is correlation, then we can come up with a line of best fit for that scatter plot. In this case, there is correlation. In this example, as x increases, our y also increases. So we have a positive correlation. In order to find the line of best fit, we first need to pick 2 points that, when connected, come close to all the points. Now, there's no easy way to do this. In order to do this, you just need to figure it out. If we drew in a line that connected this point to, let's say, this point, we would have a line that connects 2 points, but it doesn't come close to all the points. So we just need to figure out 2 points that, when we connect them, we come close to all the points. There's no exact answer for this. You just need to use your best judgment. That looks pretty good right there. If I connect this point to this point, I come close to all of the points. Step 2. Find the slope between those 2 points. And usually we write slope as a fraction. When we're working with scatter plots, when we're trying to find the line of best fit, round your answer to 3 decimal places. So in this problem, we have the ordered pair 1, 2, 3, 4, 5, 6, 7, 7, comma 2, and 1, comma negative 2. To find the slope, I'm just going to use the slope formula. 2 minus negative 2 over 7 minus 1, which is 4 over 6, which is 2/3. Notice that my slope is positive. Rounding 2/3 to 3 decimal places, I get 0.667. Step 3. Find the y-intercept. And again, round your answer to 3 decimal places. Only when I'm working with lines of best fit on a scatter plot do I want to round. Usually I keep my answer as a fraction, but here I'm going to round. To do that, I'm going to plug in the information that I know and solve for b. I know that my slope has to be 0.667. I know that when x is 1, y is going to be -2. Now I just need to solve for b. So I know the slope of my line, I know the y-intercept. My last step, write the equation. In this case, I'm going to have y equals 0.667x minus 2.667. When I look at the graph, that makes sense. I have a positive slope, and my y-intercept is about 2.667. Now I can use that equation to predict other answers. If I input a value for x and I do the math, whatever I get for y will be a point on this line, and a point on this line will be a pretty good predictor for this set of data. If I plug in a number for y and I solve for x, that's going to be a pretty good indicator of what's going to happen for this set of data. So the line of best fit is used for predictions.